All right, ladies and gentlemen, this is page 40, number 5, I think it's 5, right? B. And the trick in this question is they don't tell you how tall this triangle is. You have no choice but to figure that out yourself. So, looking straight at that triangle, actually, I'm going to redo that, make that, oops. I'm going to make that a bit bigger, actually, so that it's easier to see. I'm going to actually make it nice, too. Make a nice triangle. There we go. Nice triangle. Okay, we know that it's an equilateral triangle, so all the angles are the same. And we know then that if we cut this with a height in half, it actually does split the bottom line in half. That's only true if this was equilateral or isosceles. It's equilateral, so I know that those two lines are the same. I also know that the side length is 2.8. So that means that's 2.8, that's 2.8. This whole thing is 2.8, but from here to here is 1.4. So now I kind of think of this as just one right triangle. I'll shade it green, where I would like to find its height. I have to do this in order to find the area of the triangle. So I break out Pythagoras. Does everybody remember Pythagoras? A squared plus b squared equals c squared. Remember when we use Pythagoras that c is always the hypotenuse, and that's this 2.8 line. It doesn't matter whether I call this one a or this one a. It really doesn't matter. I'll call the height I'm looking for my a. The b number is this 1.4, half of all the way across the bottom. And that right there is my Pythagoras. So from there, I know that h squared would equal 2.8 squared minus 1.4 squared, right? The idea of solving for h, I have to isolate it by moving this to the other side. So h squared is going to equal whatever 2.8 squared minus 1.4 squared is. That's 5.88 and change. And then h would be the square root of that number. Oh, my bad. This was actually 5.88 exactly. Turns out 28 and 14 are part of a Pythagorean triplet. And 5.88 square rooted is 2.4, and then there's change. Then it's the thing after the 4 is a 2, then there's a 4, there's an 8. I'll round it to there, but I'm not actually getting this number off the screen on my calculator. I am going to hang on to it because I will need it a little later. In fact, I'm going to need it to figure out the surface area. So let's do that now. Let's bring the question down here. Now that I've got the number I need, oops, that's what I want. Let's calculate the surface area. So what is the surface area? Well, this rectangle here has to be calculated as if, well, let's see, as if it has a hole in it, but the rectangle that makes this hole is actually exactly the same as this rectangle here, because it's an equilateral triangle. So that means I can just say that the surface area here is length times width, so 2.8 times 4.8, doubled because there is a top and a bottom. And I'm going to just pretend there's no hole in it, but now I realize I've already counted that rectangle. I still have another one of these rectangles on this side, and it is 1.2 by 2.8. Then I have to calculate the two triangles, the one at the front and the one at the back. And a triangle is, again, base times height divided by 2. The base is 2.8. The height is that number that we just figured out from h, which is 2.42. Again, my calculator has other decimals on it. And the formula is base times height divided by 2, but there's two triangles, so I got to double that, which means the 2's just cancel. And then finally, I got to add up the 4 walls around the bottom. 2 of them are 1.4 by 4.8. That's the front and back. And 2 of them are 1.4 by 2.8. That's the left and right sides. So that should do it. A lot of decimals here, so I think I'll go to my calculator and punch buttons. One. Okay, after punching buttons, we ended up with 58 point, it actually ends up being 29 and change, but we'll round it to 58.3 centimeters squared, and that's what we're supposed to get according to the back of the book. So that's that question.